Hello, my name is Austin Barnes, and I'm a director of the Materials Chemistry and Surfaces group at Covalent. Today, the client was faced with a big problem in the bond uniformity of their parts. This is a critical issue for the thermal reliability of their components. Today, we are using Scanning Acoustic Microscopy, or SAM, to assess the bond uniformity. SAM is useful at looking at defects such as voids, delamination, and cracks within the internal structure of parts. Sound waves are used to reflect off of an interface between the glass and the adhesive in this type of application. We can see there are some regions that have relatively good bond uniformity where sound is transmitting relatively easily, whereas we can see other regions where sound is not transmitted very well and reflecting very strongly. Sound waves reflect off the interface between glass and the bond layer due to acoustic impedance mismatch of the two materials. When the interface is well bonded, reflection is low and sound readily transmits. However, when air is present, reflection is high. This gives us contrast and can image defects down to a few microns. Parts are submerged in deionized water. This water acts as a coupling medium for sound waves. Then we have an acoustic transducer that transmits and receives ultrasonic pulses. Each transducer is designed for a specific frequency and focal length. In this particular application, we're using a 75 megahertz. Now we can see during the scan, the surface echo and bond interface echo. It's the bond interface echo where we can see voids. Here we can see these bright regions, these are the voids. And everywhere else where that's dark is well-bonded material. Here we can see an image of the surface echo. So what the surface echo is showing just the top surface of the part. Here we can also see the bond interface echo image. And in this image, we can see the voids and we can see the other regions that are well bonded. And this is an image of the time of flight thickness map. This shows you basically a topography of the voids within the bond layer itself. We can also do an X-gate analysis. So in the X-gate, we can take this entire gate of time and chop it up into very small slices. And within those slices, we can capture additional information about where voids are occurring within the entire adhesive thickness itself. And so this is really cool because we can see essentially a time lapse of the bond uniformity and where the voids are occurring within the entire thickness of the adhesive. If you have a similar problem or interested in learning more, we offer 30-minute free consultation. We also offer live sessions either remotely or in person to demonstrate and educate our customers. If you are interested in just learning more, please reach out to us through our website and looking forward to getting in touch. Thank you.